Hey guys, this is video 14.2. We're going to learn how to assign oxidation numbers in this video. This is a huge critical skill that you've got to be able to do. Without being able to assign oxidation numbers, you won't be able to understand anything else we do in this redox unit. So take some time and really practice this and master these rules to be able to do them quickly and correctly before you really move on. So if you need to take a day to watch this video and just do practice and ask questions in class, do it. Don't rush through this, okay? Now, the rules are here listed out for you. We're going to kind of go through, I'm going to explain them, and then we're going to do a couple practice problems together. But you've really got to practice this on your own. So don't skimp and only do a couple practice problems because, again, without being able to assign oxidation numbers, you won't be able to identify the rest of what we're going to be doing. So follow the rules that we're listing here, and then use your periodic table as well. So if you don't have your periodic table out right now, get it out, okay? Or borrow one of mine or something, because you can't do this without your periodic table, all right? Especially early on. Now, the more you practice this, the faster you're going to get, the more you're going to remember these rules, okay? So really make sure, again, like I said, you get doing the practice and stuff. Don't skip on the practice. I got plenty of practice that I can give you. A highlighter is going to be something that you probably want to have as well, or just a colored pencil is something to kind of highlight the important information here as we go through and talk about it. So let's jump in. First rule, guys, and this is one that people will forget about the most, pure elements, okay? Oxidation number of 0. What that means is when it's an element by itself, so something just like sodium or sulfur or whatever, when it's not bonded to anything else, it's 0, okay? It's neutral. No electrons have been gained or transferred. Rule number 2, the more electronegative element is assigned the number equal to the negative charge as it would have as an anion. The less electronegative atom is assigned a number equal to the positive charge it would have as a cation. So guys, basically what this is saying, the more electronegative element is going to get the top number on the periodic table. So we talked about, I showed it to you in the last video, the more electronegative element is going to have whatever the top number listed there will be. Okay, in that box. Now you might think, well, how do I know if something's more electronegative or not? One, table S, you don't have to write this down. Table S, guys, is your resource. You have that. You have all the electronegativity values listed there. But remember, the further to the right you go, all right, on the periodic table, the more electronegative it is. And then up as well. So something like fluorine, which brings us to our next rule, fluorine always is a -1. Okay? No matter what, fluorine is -1 because it's the most electronegative. It's pulling in those electrons means it's always going to be an anion. The only time fluorine is not a -1 is if it's by itself, right? We just said that in rule number 1. That trumps anything else. So if it's by itself, it's going to be 0, but in a compound, it'll always be a -1. Rule number 4, and again, I know I'm going to be going through these rules, guys, kind of quickly because I could sit here and just, take some time and really read every rule out, but they're just words. You're going to have these. You can look back at them. You're going to look back at them. I want to get us into doing some practice together and kind of explaining it to you that way. So, rule number 4, oxygen has an oxidation number of -2 in almost all compounds. Okay, there's only a couple special ones you've got to be on the lookout for. So what I encourage my students to do is, when in doubt, go with -2. Okay, when in doubt, oxygen's a -2. But I guarantee you that there's a high likely probability that you're going to see one of these what are called peroxides on the Regents exam. It's got a general formula of X2O2. The big one you'll probably see is H2O2, hydrogen peroxide. Guys, if you look on your polyatomic ion list, peroxide looks like this, okay? It's a polyatomic ion. Notice how there's 2 oxygens here? Well, 2 oxygens have to equal to a -2 charge. That means each one has a -1 charge, okay? And that's what this is saying, is when it is a peroxide, it's got a -1 charge. If it's with some other halogen that's more electronegative, then it would just have to be the positive to balance it out. Again, when in doubt, go with -2 because odds are in your favor that oxygen is a -2. This is the one for sure to be on the lookout for, and maybe this guy, okay? So just be on the lookout for it. if you follow the rules and just think through kind of the ones that we've done before, they kind of take precedent, okay? Just keep those in mind. Again, the more practice you do, the more you'll see this and the more familiar you will become with it. Rule 5, hydrogen is always a +1. Oh, stupid highlighter. Hydrogen has an oxidation of +1 in all compounds that are more electronegative than it. The only time hydrogen is going to be a -1, it's a -1, guys, when it's with metals. Okay, so something like lithium hydride or sodium hydride or magnesium hydride or zinc hydride or something like that, when it's with a metal, it's a -1. Every other time, it's a +1. Remember, it acts like a metal. But remember, guys, metals, we know this already, metals are always going to be a positive charge because they don't have multiple oxidation states in terms of groups 1 and 2. Okay, group 1 is always the charge. If you look on your periodic table right now, it's got 1 oxidation number up there, bam, done. Same with group 2. The transition metals, they can be, 1 or 2 different charges. We've done that already. A lot of times, guys, what you're going to see here are polyatomics you're going to be dealing with the oxidation numbers, and then covalently bonded compounds when you have nonmetals bonded to each other. So that's really where these rules are coming from. Rule 6 is pretty simple. The algebraic sum of all the oxidation numbers is equal to 0 in a neutral compound. Neutral, the sum is 0. If you have something like a polyatomic ion, okay, the sum of all of the oxidation numbers excuse me, sorry. The sum of the oxidation numbers, guys, in a polyatomic ion is equal to the charge of the ion. Okay, number 8, covalently bonded atoms. Oxidation numbers can also be done with ionic compounds. Ionic compounds tend to be a little bit easier than than covalent ones. So I know I went through those rules, guys, very quickly. I tried to point out the highlights. You're going to use them to go back. Look back at them as a reference. Don't just sit there and be like, I don't know what to do. You have it here. Yes, you've got to read a little bit, but it's there. All right, let's jump in. All right, and do a couple practice examples together. Then you're going to try a couple on your own and then continue working on the practice sheet. So sulfate, you should be able to know what it is by now. Sulfate, 8, so it's a polyatomic. So it's going to be SO4 2-. So the first thing that should jump out to you guys is, what is my overall charge going to be? When I add all the oxidation numbers together, what does it have to be? It's got to be equal to -2 because that's what charge we have. So I'm going to kind of set this up as like a math problem. All right. Now, you're always going to know at least one of your oxidation numbers, okay, based on the rules that we have. In this case, with sulfate, we're going to know oxygen because, again, oxygen has an oxidation number of -2 in almost all compounds. The only time is when it's a peroxide or when it's with a more electronegative atom like the halogens. Here, it's not with either of those, okay? So it doesn't have that S2O2, which would be a peroxide. It's going to be a -2 charge. So now ask yourself, how many atoms of oxygen do you have? We have 4. So I'm going to kind of just make a little math problem here to make it a little bit easy. Eventually, you'll probably be doing this a lot in your head. So 4 atoms of oxygen, okay, what's the charge? -2. So what I'm doing here, guys, in the parentheses is my charge. I'm going to write that in red. So this is my charge. This is the number of atoms. Okay, just kind of as a reference point. Well, all of them, all the sum of all my different elements have to equal -2. So that means I'm going to add in sulfur. Well, think about it. How many sulfurs do you have? We have 1, and we're looking for the charge of sulfur now. Okay, so I've set this math problem up. Again, some of you, who are quick with math, you can probably do this in your head. And that's fine early on, as long as you're doing it correctly. But for those of you who are a little bit, struggle with it and don't like math, hey, this is going to be an easier way to kind of help you with that early on. So solve for x. X -8 equals -2. So I need to add this to get it by itself. So that means x is going to, add 8. I kind of jumped ahead there. 2, 8. My answer is going to be +6. So oxidation numbers for each element, we're going to jot these down over here. S is +6. Oxygen is -2. Now, you may be thinking, well, hey, isn't oxygen -8? The total charge, guys, that oxygen brings to this compound is -8, but each individual atom's oxidation number is -2, and that's what these problems are looking at, is the individual atom oxidation numbers, okay? So if you feel confident, go try these last three. I'm going to work through them as well, so you can pause the video and work on them yourself if you want to. All right, so here we go. H2SO4, I'm going to set it equal to the charge. There's no charge there, so it's 0. Everything has to add up to 0. Now, with a compound, guys, that has 3, you're going to know the first and last. Usually it's that middle guy is what you're looking for, okay? So oxygen, it's not a peroxide. It's not with a halogen, so we know its charge is -2. I have 4 of those, okay? Hydrogen, it's always going to be a +1 unless it's with a metal. Well, there's no metals here, so I know its charge is +1. Okay, sulfur is the guy that I'm looking for again. So I've set up my problem. X is the charge I'm looking for. I've added how many elements I have or how many atoms I have. So this is 2 plus X minus 8 equals 0. So when I solve for X, 2 and -8 is going to be -6. So add that over. This is going to be +6. Again, write them all out. Hydrogen's charge, or oxidation number, guys, is +1. Sulfur, we solved, was +6. Oxygen, -2. Okay, it's individual atoms again. We're not interested in their total charge. We want their individual oxidation numbers. Okay, so again, if you feel more confident now, if I went too fast, you can ask questions about how I got it. Call me over, all right, or ask a friend. Go back and rewatch it again. Pause the video, try these next two on your own. If not, I'm going to go through and do them right here as well. All right, total charge, start with that. Everything's going to add up to 0. I've got 3 oxygens. I have 1 sulfur. They all have to add up to 0. Well, again, look at our rules. Oxygen, guys, is a -2 unless it's with a peroxide, which doesn't have this general formula, and it's not with a halogen, so we know it's going to be a -2 charge. Like I said, 98% of the time, most of the time, guys, when in doubt, it's -2 for oxygen. So that means I'm looking for sulfur. So X minus 6 equals 0. X is going to equal 6. That means sulfur is a +6 charge. Oxygen is a -2 again. Now, do you think, guys, sulfur is only going to be a +6? No. It just happened to work out that way in these examples. Don't assume that sulfur is always going to be a +6, though. All right, last one, a little bit more challenging. Okay, now you could break this up into 2 things. Okay, kind of 2 ways to do it. You could already isolate nitrate, thinking, hey, each of those has to add up to, when I add nitrogen and oxygen together, it's got to have a total charge of -1 because that's nitrate's charge. But the total charge here on the entire compound is 0. Well, break it up. Figure out how many I have. I have 1 calcium. Calcium only has 1 oxidation number. It's a +2 because it's a metal. Plus, how many nitrogens do I actually have? Oh yeah, right, we got to distribute that in. There's 2 nitrogens plus how many oxygens? 6. So again, I either know nitrogen's charge or oxidation number, or I know oxygen's. We don't have any rules, guys, about nitrogen, so it means we're going to know oxygen. Again, doesn't follow the exception, so oxygen is a -2 overall, which means I'm solving for nitrogen's charge. So do the math. 2 plus 2x minus 12. So that's going to be 2x equals 10. X would then equal 5. So if I'm going to write this out, I'm going to erase this just to give me some more room to write it. Ca plus 2, nitrogen plus 5, oxygen minus 2. If you're confused, guys, I promise you the more practice you do, you'll get used to the rules. It'll go quicker. Call me over for help as well. Go ahead and work on practice number 2. There's going to be extra practice in the extra practice binder as well. Don't skimp on the practice. This is the most important thing, guys, to help you do everything else in the unit. So if you want to take a whole day to just really practice this, do so. Don't rush through this, okay? This is super, super critical for everything else we do. Till next time, I'll see you later.